Welcome to our channel Autodrive. When discussing a U.S. Navy destroyer aligned with the FY 2026 timeframe, we are looking at one of the most mature yet forward-looking surface combatants ever built. This vessel is not a radical departure from earlier destroyers, but rather a carefully engineered evolution that blends proven combat experience with new generation technology. The U.S. Navy has designed it with the understanding that future naval warfare will be faster, more data-driven, and far more complex than before. As a result, this destroyer is built to operate in highly contested environments where air, surface, subsurface, space, and cyber threats all exist simultaneously. Every part of the ship, from its hull shape to its digital backbone, is optimized to give commanders more options and faster decision-making power. One of the most defining aspects of this destroyer is its sensor and radar capability. The ship is equipped with an advanced, large-aperture radar system that dramatically improves detection range, tracking accuracy, and target discrimination. This means the destroyer can identify threats earlier and respond more effectively, whether those threats are enemy aircraft, cruise missiles, hypersonic weapons, or ballistic missiles. Unlike older radars that had to prioritize certain threats over others, this system can manage multiple types of targets at once without performance loss. For a general audience, this is similar to having a navigation app that not only shows traffic but also predicts accidents before they happen and automatically reroutes you in real time. This radar does not work in isolation, it is fully integrated into a wider combat network, allowing the ship to share data with other naval vessels, aircraft like fighter jets and surveillance planes, and even land-based defense systems. Power generation is another area where this destroyer truly stands out. Modern naval ships are no longer limited by weapons or sensors alone, they are limited by how much electrical power they can generate and distribute. The FY 2026 destroyer produces significantly more electrical power than earlier classes, and just as importantly, it can distribute that power efficiently to where it is needed most. This extra power capacity supports energy-hungry systems such as advanced radars, electronic warfare equipment, and future weapons like laser-based air defenses. The Navy has deliberately designed the ship with growth in mind, ensuring it can accept new technologies decades from now without requiring major structural changes. In simple terms, this destroyer is built like a future-proof platform rather than a one-generation solution. The weapons systems onboard reflect the ship's multi-role nature. At its core is a large vertical launch system capable of firing a wide variety of missiles. These include long-range air defense missiles to protect the fleet, missile defense interceptors to counter ballistic threats, land attack cruise missiles for striking targets deep inland, and anti-ship missiles for surface warfare. This flexibility allows the destroyer to shift roles quickly depending on mission requirements. One deployment might focus on protecting an aircraft carrier from air and missile threats, while another might involve precision strikes against enemy infrastructure or naval forces. The ship also carries a main gun that, while no longer the centerpiece of naval combat, still provides valuable firepower for surface engagements and limited shore bombardment. Close-in weapon systems and smaller caliber guns serve as the last line of defense, designed to intercept incoming missiles or fast attack craft at very close range. In terms of performance, speed and endurance remain critical strengths. The destroyer's propulsion system allows it to reach high speeds, ensuring it can maneuver quickly during combat and keep pace with carrier strike groups. Just as important is its operational range, which enables long deployments across the world's oceans without frequent refueling. This global reach is a cornerstone of U.S. naval strategy, allowing the ship to maintain presence in key regions and respond rapidly to emerging crises. The propulsion and hull design also emphasize acoustic quieting, making the destroyer harder to detect by enemy submarines. This quietness enhances its effectiveness in anti-submarine warfare, where detecting the enemy first often determines the outcome. The physical design of the destroyer balances stealth, durability, and practicality. The hull and superstructure feature angled surfaces and reduced clutter to minimize radar reflections, making the ship harder to detect at long distances. Unlike extreme stealth designs that sometimes compromise usability, this destroyer maintains a practical layout that supports easy maintenance and upgrades. Internally, the ship benefits from a high level of automation, reducing crew workload and improving efficiency. Advanced control systems allow fewer sailors to manage complex operations, which lowers long-term personnel costs and improves living conditions on board. Improved accommodations, better climate control, and more ergonomic workspaces all contribute to higher crew morale during long deployments. Survivability is a major focus of the design, reflecting the reality that future conflicts may involve intense, sustained combat. The destroyer incorporates extensive redundancy in its critical systems, ensuring that damage to one area does not cripple the entire ship. Key spaces are armored, vital systems are separated to reduce the risk of a single hit causing catastrophic failure, and damage control systems are highly automated. Fire suppression, flood control, and compartmentalization are all enhanced compared to older ships. From a layman's perspective, this is similar to a modern aircraft with multiple backup systems, designed so that even if something goes wrong, the vehicle remains controllable and safe. One of the most powerful and unique aspects of this destroyer is its role in network-centric warfare. The ship is designed to function as part of a larger combat ecosystem rather than as an isolated unit. It can receive targeting data from distant sensors, including satellites and aircraft, and use that information to engage threats it cannot see directly. This cooperative engagement capability allows multiple ships to work together seamlessly, dramatically increasing the effectiveness of fleet-wide defenses. For example, one ship's radar might detect an incoming missile, another ship might fire the interceptor, and a third might provide tracking support, all coordinated automatically through secure networks. Strategically, this FY2026 destroyer represents a smart balance between innovation and reliability. Instead of pursuing overly ambitious designs that carry high technical risk, the U.S. Navy has focused on evolving a proven destroyer concept with carefully integrated upgrades. This approach ensures that the ship is combat-ready upon entry into service while still offering significant improvements in capability. It also provides better value over the ship's long service life, which can exceed 30 to 40 years. In the bigger picture, this destroyer is more than just a warship, it is a symbol of how modern naval power is projected. It combines advanced technology, flexible firepower, global reach, and strong survivability into a single platform capable of handling a wide range of missions. Whether deterring potential adversaries, protecting vital sea lanes, supporting allies, or fighting in high-intensity conflict, the FY2026 U.S. Navy destroyer is designed to remain relevant and formidable well into the future.